Hi, my name's Claire Aspinall. I'm a physics teacher who's passionate about teaching physics outside the classroom as much as inside the classroom, and I'm also a gender balance officer for the Institute of Physics. I'd like to talk to you today a little bit about examples in which you can bring the curriculum to life through physics outside, but also I want to talk to you about a project that I undertook with a fellow physics teacher to complete an off-road marathon in every national park in the UK whilst carrying out science and physics experiments en route. So I'll finish off with a little video that explains what we got up to. So for chasing shadows, all you need for this activity is a compass and a tape measure and a budding volunteer. You can do it as we have been doing it here, out on a walk, or you can do it in the school playground. And effectively over the course of just a couple of hours, you'll see the shadow length change from the morning when it's going to be longer to midday when it's going to be shorter. And you can measure that change in distance. You should also be able to see the change in direction by using the compass. So the sun will rise in the east, which will mean the shadow will obviously be pointing to the west in the morning, whereas the opposite would be true after midday. The shadow will be pointing in the east because the sun will be going down in the west. It's a really easy exercise that children enjoy doing and bring to life what's actually happening as the sun rises in the east and sets in the west during the day. The second activity that I'd like to talk about is that of measuring temperature and humidity when you're outside. Now you could do this with a group when you're out on the hill on a walk, or you could simply do this in the playground. We used a device called a hobo that was very kindly lent to us from the National Centre for Atmospheric Research. However, you can get these online at a good cheap price. The hobo is attached to my backpack here, and effectively what it's doing is measuring temperature and relative humidity as we ascended and descended the Yorkshire Three Peaks. We also used it on Snowdon, we also used it in Scotland, but the Three Peaks data is particularly interesting because we effectively went up and down three peaks, so you could see a really interesting trend between the temperature and the relative humidity. The chart displayed shows the relationship that we had between temperature and relative humidity. The blue line indicates the temperature and the orange line indicates the humidity. As you can see, as we climb the three peaks, the first is the small dip, the second and third, the summit of Whernside and the summit of Ingleborough, the temperature is dropping, whereas the humidity is actually increasing. Now we would expect that because as the air temperature is cooler higher up, it's getting closer to the dew point, and this is the point at which the air can no longer hold all of the water vapour which is mixed with it, and therefore some of it condenses to form a liquid which we effectively see as clouds. The third activity that I'd like to focus on is measuring background radiation levels. So this is an activity that Pamela Ellison and I carried out during our marathon challenge. So we took a simple lightweight background radioactivity meter and basically did measurements across Dartmoor and across Exmoor and the Peak District and other regions across the UK. We used the GMC 300E Plus Geiger-Müller counter to take these readings. It's really lightweight. It measures in counts per minute, microsieverts per hour. It's got the tube is integral to the actual device itself, so it's not external. It's shown here at the back of the meter. So it's important when you're taking a measurement that that tube is as close to whatever you want to measure as possible. It measures beta and gamma radiation. It does not measure alpha radiation. The battery life of this device is very good. In fact, we didn't have to charge it at all during the multiple hours that we used it for. However, it's not the most sensitive meter. So for measuring the difference between Exmoor and Dartmoor, it was very good. And it was averaging between 20 and 30 counts per minute in Exmoor, whereas Dartmoor, which sits on a big granite batholith, it was averaging about 40 counts per minute. So there were clear differences in readings there. But if you were using it, say, to look at 10 different measurements around your school grounds, then you've got understand that the measurements might not be as accurate as you would like them to be. However, it could still prompt a really good discussion about the randomness of radioactivity decay and what might cause increases in the counts per minute versus decreases in it. Fourth activity I'd like to talk about is the physics of cycling, because there are so many physics concepts that you can cover by having fun on a bike. So I'm just going to cover a few of them. The first, which looks at stability and centre of mass, and the second that looks at gear and gear ratios. Pam and I ran through these activities with Helen and Ainsley, who are pictured here and who are part of the New Forest education team. In this first demonstration, Pam is holding my handlebars and basically demonstrating what it would be like if I did not shift my centre of mass as I was going around a corner. So now I'm stood up and I am shifting my centre of mass, which is what I would need to do on a bike. If I was going down a hill, I would shift my centre of mass to the rear of the bike, and if I was going up a hill, I would put my centre of mass over the front of the bike. I'd now like to focus on gears and a simple gear train. So what we've got here is one larger cog and one smaller cog. What effectively what we want to show is that if you turn the smaller gear, which has 7 teeth, it turns the larger gear. However, one rotation of the smaller gear will be only about a 3/4 rotation to the large gear. The alternate is true if you swap it around. So if you drive the large gear and you turn that large gear with 11 teeth by one rotation, it will turn the smaller gear nearly 1.5 rotations. Now let's see that in operation. First turning the smaller gear, which will drive the larger gear, and then turning it the other way round and driving the larger gear so it drives the smaller gear. The gear train model I have made here is really easy to make. It's just made out of paper stuck on a bit of card, a couple of pins, pinned into a corkboard so that it rotates. The great thing about this model is then you can apply it to a bike and scenarios actually cycling the bikes outside. So the way you can effectively do that is get someone to ride a bike on a low gear. They will not need to apply much force to do that, and this replicates what they would do going uphill. However, it does mean that they'll cover a smaller distance and therefore reach a lower top speed, as demonstrated by Pam here. So Pam covered a quite short distance, however Ainsley is using a much higher gear, and with one rotation of the pedal she covers a much greater distance, but she did need to apply a greater force to do that as she was turning the larger cog rather than the smaller cog. After investigating high and low gears, a fun thing is to put the learning to the test and have a bit of a race. So you can see Ainsley and Pam here. Ainsley in white is on a higher gear and is really struggling, whereas Pam is cycling with ease on a lower gear. Ainsley just beats Pam to the finish line because she can reach a higher top speed.
Okay, so if I'm going to do a den bike building exercise outside, I'd do a couple of things. I'd lay the equipment out for the pupils and I'll get them to decide what they want, how they'd want to basically build the shelter. So we would have talked a little bit about infrared radiation and what it's affected by, the fact it can travel through a vacuum, unlike conduction and convection. And based on that and some other understanding about material properties, I'd get them to decide what equipment they would like to use to build their shelter out of. They would all get 3 poles and some string, but then they'd have to decide which material to build it out of. So let's just have a run through and see what that looks like and see what infrared image comes out as a result. So 3 poles, basically they're just normal garden poles, really cheap from the garden centre. They do have a pointed end at the other end, and basically all we would get them to do they will come up with their own approach, and that's the great thing, because children love building dens no matter what age, and that's definitely something I've found. They just love this exercise. So just get them to build it wherever they want to do it. One of these on the ground. And then you can test it out. Okay, so what I'm going to do now is I'm going to go into the den, wrap a minute, I'll get the infrared imaging camera out and we'll have a look at what image we get and how energy efficient this den actually is. Okay.
You can see as I'm approaching the den that my legs are glowing white, as is my head, which reflects the fact that it's emitting a lot of infrared radiation, whereas my core body seems to be well insulated by the clothes I'm wearing. When I'm in the den, you can still see an outline of my body, so the tarpaulin isn't reflecting the infrared radiation back towards my body, it's actually letting it escape. So, conclusion of that is that den is not actually very effective at reflecting infrared radiation back into my body. This time round, once again, I've gone into the den, but I've wrapped myself in a silver blanket. And you can see straight away the effects of that. The blue darker colours indicate that less infrared radiation is actually being emitted from my body because it's being reflected back in by the blanket. When I get into the den, I pull the silver blanket up and over my head, and then what you see is very little infrared radiation is actually being emitted. So then I uncover it, and once again you see my head glowing white, emitting lots of infrared radiation before leaving the den. Okay, now that I've shown you a few ways in which you can take physics outside, some of which are short activities that are just 10 minutes long and you can do as part of a lesson, others which will take more preparation, more organisation and require more resources, I want to show you what we got up to in September. So as I said, myself and a fellow physics teacher completed these 15 off-road marathons, completing quite a few of the experiments that I've demonstrated to you, but some others as well.